So let's break this problem down. When you're adding these two numbers in base 8, different base than we're used to.
Oh.
So, Alexander, what is the first thing that you would do?
First, you would add 4 plus 7, obviously, like you would if you added in base 10.
So 7 plus 4 is equal to
11, but for base 8, it's
13.
it's going to be like 13 because even though 7 plus 3 is 10, it's base 8, so you carry when you get to 8. So, and 7 plus 1 is 8, and then there's 4 minus 1 is 3. So you carry 1.
So in base 8, what you're saying, 7 plus 1 in base 8 is what? Not in base 8, it's 10 in base 8. So now what do we have left?
No, because that's going to be 1.
So what we have left is 3, right? So what's 0 plus 3 in base 8?
3.
Still 3.
Oh, yeah.
You got it. And we just have the 1 there.
No.
So that's how we get the 3 on the end, and that's why we carry the 1 also. So do you guys want to do another addition problem, or would you like to try a subtraction problem?
Can we do a
subtraction?
How about we vote? Vote. Addition. Vote who votes another addition problem?
Majority rules. Subtraction.
Another addition? Okay.
Majority rules.
Close enough.
Wait, I have a question. Like, how would you like add 137 to base 7 plus 264 to base 8 to make the same house?
Okay, so the question was, how do we get, if we have numbers in 2 different bases, how can we add them together? The quick answer is we can't.
Oh, well, no, yeah, you can.
We always expand.
You have to convert them to the same base first.
Yeah, but how do you do that?
Well, we just did it here, didn't we, with these numbers?
Oh, no.
That's a good, that's a good idea. How about we do an addition problem exactly like
The way we
this?
expand it.
It's actually interesting that you would bring that up because a lot of times when they're doing different bases and adding things in different bases, the first thing that they do is convert to base 10. Just because it's convenient and it's easy to do. So how about we do 137 in base 13 and 260, how about 224 in base 5.
So we convert all of this to base 10?
Yep. You want to convert that to base 10?
Yeah.
Okay, let's see it.
I guess I'll convert to 137.
Yep. This is base 13 here.
Who's doing 224?
You can do that. Well, wait. Well, Justinian is doing it, but I want you guys to work this out on your boards before someone comes up and figures it out.
Wait, I want to do
that's your
224.
fifth base?
I want to do 224.
That's base 5, yeah.
Well, to the second base. No, it's power because it's on top.
What?
And then, look, I'm going to show you. 137. 1
Feel free to help each other out if you're struggling.
plus
Before you go too much farther, look how I wrote the expanded form in base 10 there. That I only had 1 digit in front of the power, right? Here you have 200 and 20. See what I'm saying? See where the difference is?
then 3 times 13. 3 times.
What's the opposite? What's
Who can I put down?
That's right.
No, it's not.
Okay, and here's another one.
Did you figure out the whole addition problem yet? Keep working on
Told me
it.
that. Guys.
Okay, I did it. One time.
You got it? Very good.
So I put it up.
Well, try to do the other one now because there's an addition problem up there. You have one part of it. So try to do the other part too.
But, so this is how
You have to convert the other one now.
Okay,
Okay, now I got it.
13.
Now you got it?
Yeah, always.
The addition part? Okay.
Then you do the math. Now do the math right there.
what does that mean
So
about?
you do that. That's how you figure it out and return to
Okay, check it.
and expand it for.
So you got it? This is your answer?
Yeah.
Okay.
Oh, yeah,
That's
250.
pretty reasonable to me.
So it's 215, then you would,
Then you do
and then you would do it to 224.
No, I don't.
277.
Yeah.
277.
We gotta figure this one out.
So Fiona got a different answer for 264 or 224 for base 5. I would double check your base 5.
Don't touch those. I just have to take it. See, you never see my face.
Yeah.
But I
I think you're good.
No, I don't. She looks like
All right, see your numbers are getting a little bit too big again. See how this is happening here? All that you need to change is get rid of these zeros. Because so when you're writing it in an expanded form like he did in base 10, you can just add like that. But really,
It's
you care
279.
about like the exponents there. All those exponents all only have one digit exponent, not two.
yes, 279. That's what we got.
You got 279.
Same thing as Fiona.
Figured out what I did wrong.
It's 279.
279.
That's
all
it,
right.
man.
If you're still a little bit confused about adding like within a base,
No, it's easy to me now.
it's easy
Yeah,
to
it's
do.
easy to me now, see?
Okay, this is where the jump is, Fiona. This might be helpful to you. This is the base 8 number line. You see how we go from 7 to 10? These numbers in front are our digits for our base 8 number.
This is what the newest one.
So that's why we go from 7 to 8. Does that make a little bit more sense?
Mr. Chris?
Yeah.
Okay, so if it's base 8, why would we just skip 9? Like, I know, like, me and Justine.
Why would you skip 9?
Yeah.
Well, because in base 8, so who wants to explain why we skipped 9 also? What do you think?
Because 8 is 10 and base 8 because there is nothing higher. Like you can't do 19 because it would like be a number that wouldn't exist in base 8.
But he's asking, why is it like
Right,
that?
yeah, why is it like...
Because
I'll
scientists
get to you in a
got
second.
together and they decided that.
Well, what digits can we use in base 8?
0 through
0 through 7. So how could you have a 9?
Well, I'm just saying, but like, I know we can use 0 through 7, but why couldn't we use 9?
Because we can only use 0 through 7 in base 8.
Oh, because every number before 8 is...
Well, how would 9 be written in base 8? What's
11.
11?
11?
Yep. And here's why.
9,
Well,
8 plus whatever is left over.
8 is 10.
yep, that's exactly right. Do you kind of, does that make a little bit more sense?
Yeah.
Because 8 goes into 9 ones and leftovers 1.
Yep, 8.
Okay.
So she said 8 goes into 9 once, and then 1's left over. So
So
that's why
then
you
it's
get
1,
11.
1.
1, 1. All right, is what you get.
Okay, now I get it.
Okay, so let's start doing some subtraction.
Yes.
You're allowed to collaborate, though. There's nothing stopping you from collaborating.
No collaboration here.
So how about
Just
326
kidding.
in base 7 and minus 2.
Would you still write them in expanded form, then do it?
Do what you think is right, and then we can. It's always good to experiment with different methods because maybe you'll find something out that you didn't realize before.
3,
I
3,
kinda
3,
changed
3.
this. I changed the first number because
They're both in base 7.
they're both in base 7.
Okay, Don have
I'm gonna have a little problem here too because 324
Yes,
is
yes,
positive,
yes.
and you would do that the right way, but you would just multiply
So
everything
here's
by it.
something that's gonna be
Haha,
tricky.
got it.
What? How do you borrow? What do you borrow?
You borrow from the 2.
You're borrowing 7. You're not borrowing. That's a good thing to be aware of. You're borrowing 7, not 10, right?
Yeah, but I don't like that.
You don't like that?
Mr. Chris,
Yeah.
would the units place be 6?
Yes.
4 9 times 3.
Okay, so I think I know how to do it.
You think you know how to do it?
Wait, so this is 6.
Not 22.
7 does 7. I have 11 minus 5 is 6.
Oh, that's 7.
7 does 7.
Okay, so we're trying. So Alexander, could you come put your solution up on the board and show why you did what he did?
How was he already done?
36.
So speak a little bit loudly if you can, as you describe what you're doing.
I got 36 too.
Okay, so obviously you can subtract 5 and 4, so you have to carry.
I'm gonna do it over here because I want to say how this is how far it went.
Instead of carrying 10, you're carrying 7. So
Okay?
7 plus 4 equals 11. So it's 11 minus
Yeah. This is
5.
the rise. So what she did was she figured out the distance from here
And
to
then
here. That was the distance from 100. I mean,
here you got 1 minus 5, so again you have to carry.
and that's what you're doing. You're finding the distance.
And 7 plus 1
There and
equals
there.
8.
And the other one is the
8
distance.
minus 5,
Okay?
that's 3.
And then when you
2 minus 2 is 0.
Okay, and 36 is in, make sure you specify your base.
this way, we have to.
Okay, did everyone hear how he did that?
Yeah, I get it.
Did you get it? Did you get it?
No.
Did you get it? No? Who got 36?
I did. Yeah, I did it.
You got 36? You got 30? Did you guys get 36? That's okay, take your time. It's important to describe a couple of things that happened here because he added 7 and 4 and did 11. But that's not in base 7, right? Why is that okay to do?
Because that's not part of the equation itself. It's just a simplification.
Yeah, that's a very good explanation, Alexander. You're simplifying it into something a little bit easier that you can work with, like base 10 is a little bit easier to work with than base 7. So he could have, conceivably, if he wanted to,
165.
he could have added a 1 here. He could have put a 1 in front of the 4, but then he would have had to convert that. This is in base 7, right?
I want you to start.
So, alternatively,
I want you to start at 0.32, go over 5, and up to 9.
it's possible to cancel this out, put a 1 there, and then put a 1 there.
But it would just be 7 plus 4 minus 5.
Yeah, so what's 14 in base 10? If 14's in base 7, what is it in base 10?
5,
6.
9.
No, 4 in base.
14 in base 7 is equal to what in base 10? No. 14 in base 7 is what in base 10? 11.
Alright, I guess it's time to go.
And that's why we can do that. He simplified, he took this problem off to the side, and did 7 plus 4 minus 5 in base 10. Because this is allowed to be converted like that. Okay, well, we're about out of time, guys.
No, we're still trying to figure out.
You guys can finish up, but everyone else can go on to their next classes.